Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review fractions. You probably already know that a fraction looks like this. It has a top number, numerator, and a bottom number, denominator. Bottom number tells you how many parts there are in total, and the top number how many parts you have. So this line here called the vernaculum, we read it as over. It really means divide. We say this is 6 over 8. It means 6 divided by 8. So for example, you might have a class of students and this might represent the fraction of students with blue eyes. That means the class would be divided into 8 equal groups and 6 of them have blue eyes. Of course, we normally wouldn't write a fraction like 6 over 8 because it can be simplified. 6 over 8 and 3 over 4 are equal. That means they have the same value. They're both equal to 0.75. But 3 over 4 is said to be simpler because it has lower numbers in the numerator and denominator. So we can multiply or divide the top and bottom of a fraction without changing its value. So the rule is what you do to the top, you must do to the bottom. So we can divide 6 by 2 to get 3, as long as we divide 8 by 2 to get 4. So equivalent fractions can help us compare fractions. And in maths, when we say compare, we mean say which is larger. So it's not easy at all to determine which of these fractions is larger. The reason it's hard to compare these two fractions is that they have different denominators. So what we can do is we can multiply top and bottom of each fraction and make them have the same denominator. Then they're easy to compare. So what are we going to make the denominator of each fraction? Well, we're going to make it a number that's divisible by 10, that 10 goes into, but 12 also goes into. So the lowest common multiple of 10 and 12, the lowest number divisible by both 10 and 12 is 60. So I can find equivalent fractions for these two whose denominator is 60. To make 9 over 10 have denominator 60, I need to times the bottom by 6. That'll make it 60. But what you do to the bottom, you must do to the top. So similarly, I can make 12 into 60 by timesing by 5. What you do to the bottom, you must do to the top. So 9 over 10 is the same as 54 over 60. Both are equal to 0.9. 11 over 12 is the same as 55 over 60. Both are equal to 0.916 recurring. So we can see very clearly here, 54 over 60 is less than 55 over 60. So 9 over 10 is slightly less than 11 over 12. All right, let's now look at operations with fractions. So when you're adding or subtracting fractions, you must first make the denominators the same, just like we did in the previous example. You can't add or subtract fractions when denominators are not equal. So let's look at 3 over 8 and 1 over 3. If I times top and bottom of this fraction by 3, top and bottom by 8, both fractions will have the same denominator of 24. 24 is the number I chose for the denominators because it's the lowest common multiple of 8 and 3. So 3 over 8 is the same as 9 over 24. 1 over 3 is the same as 8 over 24. So when you've got two fractions with the same denominator, to add or subtract, you just operate on the numerators, the top. 9 plus 8 is 17, and we keep the same denominator. So what about if we wanted to add or subtract mixed numbers? Well, it might be easiest first to convert these into improper fractions. So 2 and 3 over 5. We go 2 times 5 is 10, plus 3 is 13. So 2 and 3/5 is the same as 13 over 5, both equal to 2.6. Similarly, I go 1 times 6 is 6, plus 5 gives 11. So 1 and 5/6 is the same as 11 over 6. So now I'm going to make these denominators equal. I'm going to times top and bottom here by 6 to make denominator 30. Remember, what you do to the top, you must do to the bottom. So I end up with 13 over 5 is the same as 78 over 30. 11 over 6 is the same as 55 over 30. When I'm subtracting fractions with the same denominator, I only operate on the top. So 23 over 30 is my final answer. So similarly, when we're multiplying mixed numbers, we're going to first convert them to improper fractions. So 4 1/3 is 13 over 3. You go 4 times 3 is 12, plus 1 is 13, keep the same denominator. Similarly, 1 1/2 is equivalent to 3 over 2. When you're multiplying fractions, it's nice and easy. You simply multiply the tops and multiply the bottoms. But to make it easy on yourself, sometimes we like to cancel. If there's something on the top and something on the bottom that share a common factor, we can cross it out when the fractions are being multiplied. So both 3 and 3, I'm divided by 3. So I've got 13 times 1 is 13, and 1 times 2 is 2. This is 13 over 2, or 6 1/2. 2 goes into 13 6 times, remainder 1. So for 2 divided by 1 1/4, when you have a whole number, might be easiest to write over 1. 2 and 2 over 1 are the same. So I'm going to convert this here to an improper fraction. So we leave the 2 over 1 as it is. 1 1/4 is 5 over 4. So when you're dividing fractions, you simply flip the second fraction and make it a times. So this becomes 8 over 5, which is also equal to 1 3/5. All right, let's just look at a quick worded problem now. So my team has won 2/5 of our matches and drawn 1/12. What fraction have we lost? So what we're going to do here is we're going to think of all of the matches played as one whole, like one whole season. We want to subtract the 2/5 that we've won and then subtract the 1/12 that we've drawn, and that will leave us with what we've lost. So we're going to make 1 into an improper fraction. The lowest common multiple of 5 and 12 is 60. So I'm going to write 1 as 60 over 60. 2 over 5, well, I want to times bottom by 12 to make it 60. What you do to the bottom, you must do to the top. Similarly, times top and bottom by 5, it will make the fraction equivalent but have a denominator 60. So 2 over 5 is the same as 24 over 60. 1 over 12 is the same as 5 over 60. So now all we need to do is subtract the tops. We don't subtract the denominators. 60 minus 24 minus 5 equals 31. So we have lost 31/60ths of our matches. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.